Hi, Assalamualaikum and a very good morning to all of you. Today we will present about the metal dust explosion and fire at the AL solution, which is New Cumberland, West Virginia, which is the incident occurs at the productions area. Actually, the AL solution is the company that processes the titanium and zirconium, which is from the scrap metal, into the press compact that aluminum producer use as alloy activities. AL solution also obtain the scrap from the zirconiums and also titanium manufacturers, and also the end user add the press compact to the furnace or the molten metal to increase the strength of the aluminum alloy. AL solution received the raw material titanium and zirconium from the supplier. The metal typically arrived packed in water, but it also was packed with salts or an acidic agent such as argon gas to reduce the risk of explosion during the transit. During milling, a blade reduced the metal particle size and removed the outside surface layer of the raw material. When milling was complete, operator decant the water and fine metal particle known as a fine and send the water to the treatment tank. The mill metal was transferred from the milling tank and screened to remove any large solid. These solids were either returned to the mill for further size reduction or discard. Operator placed the mill and screen metal in tubes and then vacuum excess water into the water treatment tank. Next, operator blended the metals to ensure uniform compositions in the lots. The blended material was pressed into the 3-inch diameter compact, and then later on, the over dry the compact to remove any reforming water. Before the incident happened, there are a few consequences that happened previous to the incident. Okay, the first one, the blender pedal was striking the sidewall and scoring the houses. Maintenance adjusts the blender blade just to increase the clearance from the blender balls. And then later on, when the problem was returned, the parts of the blender was replaced. While replacing, a large glove cut in the sheath and crack in the sidewall of the blender was covered, but maybe due to the pedal blade scraping the sidewall. Then the maintenance welded this crack and continued to use the same blender. And then later on the mornings of the incident, an operator requests the maintenance replace a wound pedals in the blender. A maintenance employee retrieved a pedal from an old blender without replacing to the new units.
Okay, now I will present about the finding. So from the incident report, it shows that it is initiated from zirconium ignition occur in the blender. So why? This is due to blender blade that have been defect and not been replaced by the maintenance. This blade hits against the side wall of the blender and produce ignition due to metal contact. So this repeated impact result in hot spot where temperature is high enough to result in ignition. Next, this is the plant layout and the position of all workers involved during the incident. So, the shift supervisor is in milling room and he heard loud bang. For the second electrical contractor, which is located in hydraulic room, he saw fireball moving rapidly into his location and burn his body as he exit the production building. The third electrical contractor is in restroom. So he heard angry noise, felt strong wind, and saw orange sparking flame at the ceiling. So for the blending and press room, there are 2 operators died at the scene and press operator having serious burn, and he also died after 3 days. This picture showing the condition of equipment and parts and surrounding area of the blender after the incident. Okay, for the last part of the finding, from the investigation, it shows that the fire propagate due to open drums and tubs of titanium and zirconium at several locations. Other factor, it is because of water deluge system which functioning after fire ignition happen. This water deluge system cause hydrogen gas to produce from the reaction of molten titanium and zirconium with the water. This also contribute to the explosion. Another part, which is test analysis, have been conducted for both metal after the incident happened. It shows that this metal capable causing explosion when exposed to near heat or ignition source. AL solution also did not mitigate the hazard of metal dust explosion through engineering controls such as dust collection system. For accident analysis, we choose bow tie. So I will explain a little bit about our bow tie analysis. First, the hazard is dust explosion and the top event is fire explosion in zirconium blender. So for the left side, it is a several preventive barrier which is prevent the threat from occur. So the threat is cause of the top event. So what is the threat from this incident analysis? Is first, improper material handling, hot surfaces and heat generated, pressure control failure, mechanical failure, static electricity, dust explosion, improper plant in operation, inadequate equipment and design. So there is several preventive barrier before this threat can occur. For the right side, it consists of consequence, which is result from top event, and also the barrier, which is the recovery barrier that makes sure if the top event is reached, the scenarios does not escalate into actual impact, which is the consequence. So the first consequence is personal injury or death. The recovery barrier is activated emergency plan and also proper adequate PPE. For the environmental damage consequence, the recovery barrier is automatic fast-acting isolation valve and flame front diverter and also activated emergency plan. For the fire explosion escalation in other part of the system, as consequent, the recovery barrier is portable firefighting equipment and also activated emergency plan. Okay, let's proceed with the recommendation. For the first recommendation, they need to develop training material for all employee and contractor. They also need to ensure periodic refresher training to existing employee and contractor. Second, they need to conduct process hazard analysis as defined in an FPA. Third, prohibit the use of water sprinkler system and also water deluge system in all area of the building. And for the last recommendation, for all new and existing equipment and operation at AL solution facilities that process combustible metal dust or powder should apply an FPA and standard for combustible metal. For the last part is the conclusion. Okay, we need to know that metals and even some non-metallic inorganic material will burn or explode if finely divided and dispersed in sufficient concentration. Second, in AL solution, there is no engineering effective control for dust hazard, such as installing dust collection system that would safely remove dust during metal processing. Third, many of these type of incidents have been investigated by the CESB and repeated recommendations have been made to OSHA to promulgate a combustible dust standard.